In the previous lecture, we have discussed the uh, PDF of the Gaussian random variable. Now let's talk about the CDF of the Gaussian random variable. So, what is the CDF for the Gaussian random variable? So the CDF of the Gaussian random variable is defined as now we will replace the small x with the capital X, f of x, capital F, f of x, where x is the random variable. So the CDF is equal to the probability of random variable x that is less than or equal to small x. So incorporating the probability density function into the integral that is from minus infinity to that value of random variable x, we get f of x into d of x. Now incorporating the PDF in this integral, we will get integration from minus infinity to x 1 over under root 2 pi into sigma. Keep in mind the sigma is outside the under root, into e raised power x minus mu whole square divided by 2 into sigma square to dx. Now uh, I have to stop here. I will call this equation A, because this equation has no closed form solution. So what is the closed form solution? The closed form solution, it is an expression that can be described by finite number of operation but usually not limit, integration or differentiation. It means it cannot be written in the form of x or other uh, operation like addition, subtraction. So we can solve this integral by numerical. So the PDF for Gaussian integral was like, that was like bell shape. With its mean as mu. So this is the variable x. So I have to calculate its probability when x is less than or equal to this random variable x. Uh, so how I will solve this uh, uh, integration? For this purpose, keep in mind your calculus course, how we solve the integral. I will chop this distribution into small uh, rectangles like this. Then adding them, these rectangles, uh, I will get the area under this curve. So it will give the area under the curve. So by adding these small rectangle, we will get area under the curve, under this curve. So uh, the CDF of the Gaussian random variable, uh, this is the PDF. The CDF would be uh, this is the mean, uh, sorry, this is the mean value. As we know, the half of the probability is at mean value. So uh, here half of the probability would be at mean value. So first let's take this the distribution which has small value of sigma. I mean this one, this tight one, Gaussian distribution we are taking into account. So I will start from here. So after adding, as I will approach uh, uh, to the mean value, it become bigger and bigger. So the CDF would be like this. As I will approach to the mu, it will increase. So this is 1/2 and this is 1. So the CDF would be like this for uh, small sigma. Now, when the sigma is large, then we get the broad uh, distribution, Gaussian distribution. In this case, this one is the broad Gaussian distribution. So when I change it into the CDF, so uh, by following this PDF, uh, I will get the CDF that would be the steep. So in this case, I will get CDF which is like this. Hence, the PDF depend on the uh, on the on the shape of uh, the PDF. So in order to compute the CDF, we must do some numerical integration. CDF value we must have to do some numerical integration. Compute CDF values. So how we do the numerical integration? First, we convert the Gaussian random variable or the Gaussian distribution into standard normal Gaussian distribution. So how we do this? We convert Gaussian distribution to standard Gaussian or normal distribution. So the definition of standard Gaussian distribution is as we assume mu mean is 0 and its standard deviation as 1. So by assuming mu 0 and this sigma is equal to 1, so we will get the CDF for this situation. CDF for this situation as so I will integrate up to x e raised power x square divided by 2 into d of x. Now I will sketch the shape of this curve. This is a Gaussian random variable or Gaussian distribution. So I have to calculate its CDF for x. So I will consider the area under the curve which is less than this x. So this area under the curve gave the value of the CDF which I have to calculate. So I have to find this x is the number for which I have to find the CDF from. So this I can do from a z table which is given as this has the value of this this distribution, this standard. This is the standard normal distribution, which has mu is equal to 0, and I have to find x which is the number for which I have to find the CDF. So I use this table. So from this table it is obvious as z is is increasing. So when z is equal to 0, it has a value, its PDF is a 0. So for different value of z, it gave this table gave you the area under the curve. So for z is equal to 2, so its area under the curve is 0.477. When z is equal to, when standard deviation or z is equal to 2, in this case I have area under the curve 0.4772. Here in this table, this is the point 4 up to first standard deviation. Suppose here it has the value 0.3413. So if I take the negative and positive value of the first standard deviation, or the z, here z is equal to 1 and here z is equal to -1. So it gave you the total total area under the curve, that would be 0.03413 plus 413 from in right side of this mean, and on the left side of this mean, that is 0.0413. So the total area under the curve would be the 0.68 0.26. So similarly, you can find the value of z for its higher value. Now let's take an example. For z is equal to 2, so the probability for x is greater than this z, and z is equal to 2. In this case, as z is equal to 2, in this case I have to find the probability in this shaded region. So it would be this probability would be, I mean, up to this region the probability is 0.447. So the total probability in this region would be 0.5. So this, for this shaded region, I will calculate as 0.5 minus 0.447. So I will get 0.447, it would be 3, this would be 0.153. So to use this z table, what we have to do, first we have to convert the Gaussian distribution to standard normal distribution. To use z table, we need to convert whatever Gaussian distribution to standard normal distribution. With mu is 0 and standard deviation is equal to 1. So how to do this? How to convert this? We subtract this mu from random variable. So suppose we have to find the probability of this random variable x that is less than or equal to z. So what we do, the next step is we subtract this mu from this random variable and then divide it with standard deviation sigma. So this is exactly the standard normal distribution. A standard normal distribution is also called a z distribution, and it can be defined as x minus z is a variable. We will replace this random variable x with z, which is equal to x minus mu, that is divided by standard deviation sigma. Now let's solve some example for the CDF of standard normal distribution. Let us consider a random variable x, which is normally distributed with its mean hundred and standard deviation of 10. Assume that the value of this random variable are x is equal to x1 is equal to 110 and x2 is equal to 85. Now z would be x minus mu divided by sigma. So in first case I can find out z1 is equal to 110 minus, because its mean is 100 and standard deviation is 10. So 110 minus 100 divided by 10. So in this case I will get z1 is equal to 1. Now solve for x2, that is equal to 85. Now z2 would be equal to x2 minus mu divided by epsilon naught. x2 is equal to 85 minus 100 divided by 10. So I will get z2 is equal to minus 1.5. Now I have to find the CDF. For this case I have a standard normal distribution which has mean at its center, and on the right side the value of z is equal to 1, whereas on the left side z2 is equal to minus 1.5. Now using this z table I can find out when z is equal to 1, that is equal to 0.3413. So this is the area in this region is 0.341. So in this side I will find out the value of 1.5, that is equal to 0.4332. So this distribution, Gaussian distribution, is equally distributed around around its mean value or middle point. So on the right side, this way, the total area under the curve is 0.5, and on the left side the total area under the curve is 0.5. So in this case, at 1.5, so I will get 4.44332. That can be observed from this table. So what would be the total area if I find the total area in this case? That would be the 0.432332 plus 0.341. This would be equal to 0.77, the total area under this shaded region. So let's solve some another example that is related to how to find the area under the curve. How to find area under the curve. So there is an example. I have to find the probability when z is greater than when z is greater than minus 2 and greater than or equal to minus 2, and it is less than 0.95. So in this case I can write it as pi when z is equal to minus 2 plus pi when z is equal to so I will introduce another function. I can so the CDF can be defined another function, that is pi, that would be equal to 0.95. So in case of again I will use z table when z is equal to 2. In this case the area under the curve would be 0.477, and in case of z is equal to 0.95, so here is 0.9 in this table. So I will follow this row at 0.5. Its value is 0.3289. So 0.3289, this is equal to this and this is equal to this. So standard normal distribution is like this. So here is z is equal to 0, and when the value of z is here minus 2, and here the value of z is 0.95. So the total area under this curve would be 0.477 plus 0.328. 8 plus 7 15, 1 carry, 8 plus 2 10, 4 plus 3 7 plus 1 8. So the total area would be the 0.805. So the area under this curve, this distribution would be the 0.805. Now let's solve another example. Let's find the area or the CDF when z is, suppose when z is greater than minus 1.5, greater than or equal to 1.5, and z is less than minus 0.5. So by following this Gaussian standard normal distribution, here z is equal to 0, and here it is 0.5 minus 0.5, and here it is minus 0.5 1.5. So I have to find the area in this region, this red region. So what would be the area when z is equal to uh, 1.5? So what this would be the area. So how I will find this? In fact, on the left side, the total area is equal to uh, 0.5, and on the right side the total area is 0.5. So what I will do, the trick is, uh, 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 I will find this area, uh, the total area. I will find this area, then I will subtract it from 0.5, uh, the total area, which is 0.5. Okay, let's solve another example. Let's find the probability when z is greater than 1.5, greater than or equal to 1.5, and less than or equal to minus 0.5. So here is the standard normal distribution with mean at 0. So this is minus 1, here is minus 2, and I have to find the uh, uh, so I have to find the probability in this region. So first what I will do, I will find the probability from 0 to 1.5 up to this region, then I will subtract this region, so I will get the probability in this red region. So this is pi minus 1.5 minus, I will subtract the probability when the spread is up to minus 0.5. So first I will calculate this region, this whole region up to minus 1.5. Then I will subtract this region, so I will get this this red area. So this would be equal to, so again using a z table, when z is equal to 1.5, its value is in this table, this is equal to 0.4332. So this is equal to 0.4332. So when z is equal to 0.5, that is equal to 0.1915. 0.1915. So I will get answer by subtracting this value from this value. I will get the probability, or the area under this shaded region, that is equal to 0.2417. Okay, now solve another example. uh, uh, I have to find the probability when z is greater than or equal to 2. So for this case, here is the standard normal distribution. This is 0. So here when the sigma is equal to 2, here in this case z is greater than 2. So this will cover this region. So what I will do, the total probability of this area from right side of the midpoint is equal to 0.5. So I will subtract this region, this blue region, from 0.5. So then I would get the value the area under this red region. So that would be equal to 0.5 minus probability when z is equal to 2. So again, using this z table, when z is equal to 2, this is equal to 0.477. 0.477. 0.5 minus 0.477, this is equal to 0.0228. Let's solve another example. Find the unknown z represented by, another example is find the unknown z represented by z naught. In first case, z is less than or equal to z naught, that is equal to 0.846. So in this case, uh, uh, z is positive, so uh, we can write the probability, it will cover this area. This Gaussian curve is symmetric. On left side, the total area under the curve is 0.5 in this left side. So let's suppose z is somewhere here. So its probability, I can write this is equal to 0.5 plus x, z has some value x, that is equal to 0.846. So x is equal to 0.846 minus 0.5, that is equal to 0.3461. Hence z naught is equal to 0.3461. Sorry, x is equal to this. So from table I can find the value of z when z is equal to 0.346. So when 0.346, so here when by following, when z is equal to 1, this is equal to 0.3413. When z is equal to 1.01, this is equal to 3438. And when z is equal to 1 point, by following this column, z is equal to 1.02, this is equal to 0.3461. Hence z naught is equal to 1.02. Okay, let's solve another example. When find the probability, so this is a part, this is b part. Z is greater than minus 1.72, greater than or equal to, and less than z naught. So this is equal to 0.9345. So the total area under the curve is 0.9345. Let's suppose the total area is this region. It covers all the negative values because this is greater than or equal to minus uh, uh, minus 1 point. So I may say this is minus 1.72. So it covers all this region. So I have to find the value of z naught. Suppose this is somewhere here. So uh, when z is equal to minus 1.72 plus this is equal to x is equal to plus x is equal to 0.9345, when z is equal to 1.72. So again, following the table, this is 1. I will follow this row. This is equal to here in this column, following this column. So here is the value of 1.72. So 1.7 is equal to 0.3577. This is equal to 0.3577 plus 1.72 is in fact this is equal to 1.7. So this is 1.7, and I will move right here. This is equal to 0.4573, 0.4573 plus x is equal to 0.9345. So I will get x is equal to 0.9345 minus 0.4573. This would be equal to when I will subtract 0.9345 minus 0.4573, 345 minus 0.4573. So this would be equal to 2774. So x is equal to 0.477. So what would be the value of z naught? Z naught in this case would be equal to this is 0.477. So at z is equal to 2, the value is 0.4772. Hence z naught is equal to 2. Let's solve another example. The event, suppose an event x has normal distribution with mean mu is equal to 10. Another example. Let event ix has normal distribution with mean mu is equal to 10 and variance is equal to 9. Find the probability that it will fall. Find the probability that it will fall. So between 10 and 11. Second case, between 12 and 19. Above 13, and D part is that x is equal to 11. So in first case, z would be equal to x minus mu, that is divided by sigma 10 minus 10 divided by, so here the variance is 9. So the standard deviation would be sigma would be 3. So divided by 3, this is equal to 0. When z is equal to 10, when x is equal to 10, z is equal to 0. When x is equal to 11, in this case z would be 11 minus 10 divided by 3, 1 by 3. This is equal to 0.3. So I have to find the probability. In this case, this is Gaussian standard normal distribution. So here is the mean value, that is 0, and here z is equal to 0.3. So the area, this area would be equal to that we can find p z is greater than 0, and this one is okay, x is greater than or equal to 0, less than or equal to 11. So in standard form it would be z would be greater than equal to 0, less than or equal to 0.33. So this area would be, we can find when z is equal to 0.3, the area would be, now again following that z table, for 0.33, when z is equal to 0.33, the area under this curve would be 0.1 0.1293. So this area would be from 0 to standard deviation, or when z is equal to 0.3, this would be 33, this would be the area under the curve would be 0.1293. So solving the b part, let's find the probability when x is greater than or equal to 12, and it is less than or equal to 19. So in first case, z1 would be equal to 12 minus mu is 10 and standard deviation is 3. This would be equal to 2 by 3. So z1 would be equal to 2 by 3 is equal to 0.66. Then z2 would be equal to 19 minus 10 divided by 3, 9 by 3. z2 would be equal to 3. So in this case, z is greater than 0.666, z is greater than or equal to 0.666, and less than or equal to 3. So if we look at the normal distribution, standard normal distribution, so I can find here is the value 0.666, and here is z is equal to 3. Now look at the z table, so I can find this area, this shaded area. So this would be equal to first I will find the total this area up to this. I will find the area for z is equal to from 0 to 3. So that is equal to from 0 to 3. Then I will subtract this region. This I can show with the red pencil. I will subtract this region. So this region is when z is equal to 0.66. So when z is equal to 3, its value you can find out from table. Sorry, in fact this one is the short table. This would be equal to 0.4987 when z is equal to 0.666. So this is 0.6. I will move onward. Here 0.666 is equal to 0.245. 0.245. When I will subtract this value, so I will get the result 0.251. So in third in C case, when x is above 13, in that case the probability would be x is greater than or greater than 13. uh, so I can write it as uh, z. So z would be equal to 13 minus 10 divided by 3. This is equal to 1. Z is greater than 1. When z is greater than 1, uh, this is 0, this is 1. So I have to find the probability in this shaded region. So what I will do, the total probability on the right side is equal to 0.5. I will subtract this value from 0.5, this red shaded region. So I will subtract from 0.5. So I will get the area under this region, this I mean green blue shaded region. So 0.5 when z is equal to 1. Again I will follow this table. For z is equal to 1, its value is 0.3413. 0.3413. So I will get the probability in this region would be 0.1587. Now again, d part at x is equal to 11, I will get z is equal to 11 minus 10 divided by 3, that is equal to 1 over 3. Z is equal to 0.333. So the probability x is equal to 11 would be probability of z is equal to 0.33. So at this region, at any point, the probability density would be equal to 0. Okay, another example, let's solve another example. uh, uh, a production line manufacturers manufactures 1,000 ohm resistor that have 10% tolerance. Suppose if the probability if its resistance is 1010 or 10% tolerance mean the 10% of 1000 would be 100. So if the resistance is 900 or 1100, this resistor would be acceptable, otherwise it will be rejected. Let x denote the resistance of a resistor. Assume that x is a normal random variable. mean 1000 and variance as 2500. Find the probability that resistor, we have to find the probability that a resistor picked at random will be rejected. So here we have to find the probability that resistor picked at random will be rejected. So we have given mean value that is equal to mu, that is equal to 1000 in this case, and the variance is 2500. So the standard deviation would be 50 in this case. So we have to choose the event that the picked resistor would be rejected. So we have given 10% tolerance if the resistance of the resistor is 900. If we subtract 10% would be the 100. If we subtract 100 from 1000, so if the resistance is less than 900, so it will be rejected. When x is less than 900, so or x is greater than 1100, so that resistor will be rejected if their resistance is greater than less than 900 ohm and greater than 1100 ohm. So event is A. So these both, x is less than 900 and x is greater than 1100, these both are mutually exclusive. So we can write x is less than, these both are independent event. X is less than 900 when x is, and x is greater than 1100 is equal to pi. So the probability of A would be equal to the probability x is less than 900 and x is probability of x greater than 1100. So we will change it into the standard normal distribution form. So first CDF of x is equal to 900 plus, in this case as x is greater than 1100, so the CDF would be 1 minus f of x into 1100. So f of x 900 can be written as pi of 900 minus mu is here 1000, sub 900 minus 1000 divided by sigma is 50 here. So this would be equal to minus 2, and minus 100 divided by 50 is equal to minus 2. So I can write it as 1 minus pi of 2 when z is equal to 2. So for CDF f of x is 1100. In this case I can change into standard normal distribution. So this would be 1100 minus mu is 1000 divided by 50, that is equal to pi is equal to 2. So I will incorporate these both values into equation. I call this equation A, this is B, this is C. Incorporating B and C into A, I will get the probability of A would be equal to 2 into 1 minus pi of 2. So this is approximately equal to 0.045. Hence the probability for the rejection of of this resistor would be 0.045. Thank you. Next we will see the different other form of distribution like binomial distribution, Poisson distribution in the next lecture.